When you start 26, right away you should be able to tell what shape it is. The hyperbola, good. Has to be a hyperbola because there's a subtraction. Now, what's underneath the y plus 4 quantity squared that you just don't see? A 1. So I'm always going to write over 1 if there's nothing there. That way I know that there's something there. Okay. Now start listing. We start with our center. Our center is our values of h and k. Well, the value of h is what? 0. It's 0 and negative 4 for h and k. Your value of a squared, since remember, a squared is always the first term for a hyperbola because that's what the formula tells you. So your a squared is 16, your b squared is 1, c squared. For a hyperbola, what do you do to find c squared? Do you add a squared and b squared or subtract it? And why? You remember? Very good. It's the opposite of the sign given in the formula. So it'll be a squared plus b squared, so that is 17. Okay? Everybody okay with that? All right. Now I figured out my value of a is a plus or minus 4, b plus or minus 1, and c is plus or minus the square root of 17. So far, so good? Okay. A. What does A represent? The distance from what to what? Center to the vertex. Good. Since this is an x squared first hyperbola, I gotta look at my formula, figure out which direction it goes. So looking at my formulas here, hyperbola option 3, x squared comes first, which means what way do these go? They go out. They go left and right. Okay? They're gonna go left and right. So I'm gonna go back to my picture here and just do this real fast so that way I remember that they have to go left and right. Okay? Plot your center. Your center is located at 0, negative 4. Your value of A is the distance from the center to the vertex. It means I have to go left and right. Well, I remember if I was going to the left when you guys were looking at it. Yes, I did it right. Go left 4 and right 4, write down the ordered pairs. So my vertices are at negative 4, negative 4, 4, negative 4. You okay with that?
Yes.
Okay. Co-vertices. Co-vertices means I have to go up and down. My co-vertices, if I go up and down from there, it just means I'm at negative 3 and negative 5. 0, negative 3, 0, negative 5. Now I draw my little rectangular box around it. Okay? Not to scale, just squint, it'll be just fine. Slopes. Your slopes here, I went up 1 over 4. Or I went down 1 over 4. So I have two slopes. One's positive, bless you, one's positive 1/4, the other one is negative 1/4. Lastly, vertices. Vertices are at the C value, the distance from our center to our focus. The C value is the distance from our center to the focus, and if the center to focus is the square root of 17, that's just a smidge more than 4. A smidge more than the square root of 16. So we can't really graph that cleanly, so I'm just going to put it here and here. Plug the asymptote and go. And then I just label it. Okay? That value of C I added to the vertex, and I moved it left and right. So do I add the root 17 to the x value, or do I add it to the k or the y value of the vertex? The x. So my foci, since my center is at 0, if it was at 8, I'd write 8 plus the square root of 17, 8 minus the square root of 17. But since it's at 0, I'm just going to write plus, or just write root 17, comma, negative 4, negative root 17 common 4. Negative 4, excuse me. Because I don't have to write it as 0 plus that. This is the only one you don't have to worry about it. Okay? What's left for me to do? The equation of the asymptotes. But hey, guess what? What's your y-intercept? Again, your y-intercept is the same for both of these because it's at the ordered pair of 0, negative 4. So your two equations are really easy to write. You don't have to do much here. It's going to be y equals negative 1/4 x minus 4 and y equals 1/4 x plus 4. I'm sorry, minus 4. You didn't have to use point slope form to get that because it's on the y-intercept. What do you got? This is a great conversation. I appreciate the time you and I have together with these conversations. Okay? Not terrible? All right, let's make it look really weird then. Let's get fun. Today, we're going to take, same stuff, 6, yeah. So this week, guys, so you guys all are aware, this is the last bit of 10.6, and it comes with a lot of completing the square. We're also going to talk a little bit today about how do you write the equations given a shifted conic versus being at the center. It can get a little fuzzy if you're given root things, and we'll talk about that towards the end. Tomorrow I've got like 6 problems tonight of this style. I've also posted a review sheet with answers of this same style as well. And then tomorrow I already posted it for tomorrow, another review thing with more problems like this with solution guides already on there as well. So between tomorrow we're just going to be doing problems of all shifted things. Wednesday we'll test on conics with just shifted things. There's no reason for us to do non-shifted because might as well just do full shift because it's all there. And you can have the calculator because the calculator has all the formulas on it. Okay? So the formatting and the style of it's going to look very similar to what we did with the non-shift, but now it's just going to be moved around and a lot of other craziness going on. So we all know where we're at. Then on Thursday, between Thursday and Friday, we're going to start working with polynomials. Any nomials? Yes, ma'am. What? Conics, all I'm going to do is, it's all the conic stuff, but it's just all shifted conics. I'm not going to go to, because the stuff we did before was all non-shifted. I'm just going to show everything with shifts. But you have to know how to do all of it. All right, so now here's what I would do if I were you guys from here on out. We got a lot to get through here today. We want to make sure we have time. If I were you, from here on out, you've probably already written this one down. Each and every time from now on, here's how I would write these problems down. Since we know that we have to get it into this conic form where we have to complete the square stuff, I will always write down these problems. I hope that you do this, is just by starting by grouping your x values together and your y values together and moving whatever the constant is. When you write down a problem like this, whether it's from the book or a worksheet or note-wise, do this step first. Just start shifting things around, moving them together. Because you know that when you go to complete the square, what does the value of the x squared term, or the coefficient of the x squared, always have to be in order to complete the square? 1. So that means right away, plus what? I'm getting there. I'm getting there. You're a step ahead of me. Before I do the plus blahs, I got to factor out that leading term coefficient. So here I got to take out that 16x, or sorry, 16. I'm going to get x squared plus, well, 24 divided by 16. 24 divided by 16, they're both divisible by 4. So you get 3 halves. Okay? Okay. Same deal, take out the 9, we get y squared minus 4y plus blah. Now, since I took out parts, I gotta remember to put parts back in on the other side. So here I have minus 23 plus 16 times something. Plus 9 times something. Whatever coefficients you take out, you got to put back in on the other side. Okay? Whatever you take out, you got to put back in on the other side. Now we complete the square. Yes, 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 yes. What thing? We did. I get 16 times something, 9 times something. The something in parentheses is playing the role of the little blank. Because I took it out, I'm putting it back. That's the law. All right. Now we complete the square. What's half of 3 halves? 3/4. Just multiply by a half. When you square 3/4, you square the numerator and denominator. You get 9/16, which you put to the other side. That's the rule of completing the square. Half of b squared adds both sides. Okay? Same deal. What's half of -4? -2. When I square it, what do I get? 4. So I add 4 to both sides. Okay? Now we have to figure out the other side. What's 16 times 9/16? 9. See how quick that works? What's 9 times 4? So you have -23 plus 9 plus 36. What do you get? Nine and 36 is 45. 45 minus 23, you get 22. God, this one's awful. Yeah. This one gives you awful values. But anyway, let's read this back. Okay. Now, remember that little shortcut I showed you guys before about when you had the complex fractions? When you had a number divided by a fraction, you basically brought up the lowest number, brought up to the numerator of the top one. When we did this one, how did I rewrite that? Remember? This says 3 divided by 7/4, which is 3 over 1 times 4 over 7. So you get 12/7. Basically, take this value, put it up here. Okay? So when you get to something like this, and you bear with me for a second. That's technically what that would look like. Work backwards from how you work with a complex fraction. Now, just by looking at this, is it an ellipse or a hyperbola? It's an ellipse. From here, what we would have to figure out is which way is it being stretched, up and down or left and right. In order to do that, you just have to get the decimal equivalent of what 22/16 is versus 22/9. Okay. And you would figure out which way it's being pulled. Now, graphing this one with these god-awful a squared values, well, they're not that bad. It's square root of 22/4. So, I mean, it's not terrible, but it's god-awful. I wouldn't make you guys graph something with this horrid of a squared and a b squared. Okay? But that's kind of where you would go with it. So let's see, 22/16 is a little bit more than half. 22/9 is more than that. So this one, the a squared value is the 22/9 being pulled up. That's really all you'd be able to do this one. I'm not going to make you graph something with those awful values. But that's the process by which we would go. Just so happened out of the 15 problems in the textbook, I randomly selected the one that was the worst. Merry Christmas. All right, let's do another one. That won't be as bad. I try not to. All right. Okay. Now, when you write this one down, what are you going to do? Right away. So as you're writing this one down, I'd write it as 9x squared plus 36x plus 4y squared minus 24y is negative 36. Yes, ma'am. Because I have to leave it as a trinomial, and then when I do that, that way I can create a perfect square triangle. Because what you're trying to do is get to a junk squared. Junk squared is junk times junk, so if you factor to FOIL that out, you get x squared plus something x plus. That's why we leave the x value. Okay. What's the GCF, or what's the coefficient in front of the x squared for the first part? The 9. You take the 9 out. You have x squared plus 4x plus blah. Take the 4 out. Y squared minus 6y plus blah. And whatever we take out, we just got to remember to put back in. What's that? Okay. Process. When you complete the square, you take half of b. What's half of 4? 2. That value of 2 goes into the parentheses. When I square it, what do I get? 4. So 4 goes to both sides. What's half of negative 6? Negative 3. So the negative 3 goes here. When you square negative 3, you get 9. So you put 9 in both spots. What's negative 36 plus 36 plus 36? 36. Okay. Now what do you do? There you go. Subtract 35. Now, a minute ago, we had that problem that gave you a fractional h value. Remember, we had that 9 or 3 halves, and you squared, you get 9/4, and then you added it over. And the numerical value of like was 16 times 9 over 16, it gave a clean number. It just so happened the other numbers looked like crap. So it is possible to still get fractions in these things and still have numbers that are clean. Okay, so don't freak if you get a fraction at any point. Simplify this through, you get x plus 2 quantity squared over 4 plus y minus 3 quantity squared over 9 is 1. What shape is it? It's an ellipse. And which way is it being pulled? Up and down. Good. So let's go through graphing then. Did you forget to put it back to the other side? Okay. When you take out the 9 here, you have to take out the 9 here as well. When you're completing the square, you have to take that GCF through. You can't just pull the 9 out of the first term. That's why when you rewrite it like this, we take the 9 out. This should have been a 9 x squared plus 4x. 4 y squared minus 6y. You take the GCF out of the first term. That's where that messed up. You're going with that? So, what's your a squared value, guys? 9. B squared is, what's your c squared value? 5. So a plus or minus 3, b plus or minus 2, c plus or minus square root 5. Okay. From there, we start plotting. Where was your center at? -2 and 3. Good. This one should be pretty quick. We know it's stretched vertically. A value is always the distance from the center to the vertex. We have to go up and down how many spots? 3. So my vertices are at -2, 0, -2, and 6. Co-vertices are going to go left and right in this case. So if I go left and right from -2, I wind up at 0 and at -4. -4 and 3, 0 and 3. Foci I have to add and subtract root 5 to which value? The x value or the y value of the center? Y value. So I know that my x value doesn't change. It'll be at -2, and then it'll be 3 plus root 5, and -2, 3 minus root 5. Square root of 5 is a little bit more than the square root of 4. Put a couple of dots. And draw your ellipse. Are there asymptotes for ellipses? No. There's a lot, yeah. I mean, One more of these. Oh, we did this one? Oh, sorry. Never mind. Yeah, I think. Sorry about that. No, I wanted to make sure I got another one of those with these switches in it. Oh well. All right, so we got negative, guys. We have a negative 2y squared plus x minus 16y minus 30 is 0. Okay? So what does this mean this has to be? It's got to be a parabola. More specifically, which type? It's a y squared parabola. It has to be a y squared parabola because there's just a y squared. So we know that it's going to be a y minus k quantity squared equals 4p x minus h. So for somehow, some way, we have to get it to look like this. Now here's an easy way to start this. Is it okay that I rewrite it as x minus 30 equals 2y squared plus 16y? Is that okay? What did I do? Yeah, I just added the 2y squared and the 16y to the other side. Now, is there anything that says that I can flip this? It says that I can't? Is there any rule that says I can just flip them on the other side? So I just rewrote it the other side because that's what we're used to seeing in terms of the formula. You okay with that? Okay. I still got to complete the square. So what do I have to take out on the left? 2. Okay. And I'm just adding to the other side to keep it balanced. Yes. It was at the top, yes, and then I added to the other side to make it positive, and that's why I also added the 16 to make that positive. Just doing a quick little addition stuff. What's half of 8? 4. So I get 2 times the quantity, excuse me, y plus 4. When I square it, what do I get? Be okay with that? Okay. So now I'm going to get 2 times the quantity y plus 4, quantity squared equals x plus 30, I'm sorry, x plus 2. All right. I'm close. I'm close to now getting it. What do I do with that 2? Divide it or multiply by what? 1/2. So when I multiply everything by a half, I get y plus 4 quantity squared equals 1/2 of x plus 2. I don't distribute it in. because now it looks like 4p x minus h. That's the trick. Okay, you see that? That's the trick for that. Okay. By multiplying, one second. By multiplying by the reciprocal, it's the same thing as divided out. Yeah, bud. Yeah, you get divided by 2, but what are you going to write on the right-hand side? That's what I'm saying. You want it to look like that 4p x minus h stuff? You do, but if you just write it x plus 2 over 2, you have to rewrite it with that 1/2. Yeah, that's where I'm getting at that. Don't be afraid of the fraction. Okay? Now, where's your h and k? What's your center at here, guys? K is -4, h is -2, so your center at -2, -4. I know that my 4p is playing the role of 1/2. That makes p what? 1/8. Good. Makes my p value 1/8. So which way does this open? Up, down, left, or right? Right. It opens to the right. It's y squared positive p value. Okay, y squared positive p value goes to the right. So that gives you center at -2, -4. Your center is also the vertex for a parabola. Your focus moves to the right 1/8. So your focus is still going to have the same y coordinate, but I have to add an 1/8 to -2. Now, I'm sorry, what? No, you have a calculator. Yes, ma'am. How do I get the focus? The 4p is playing the role of 1/2. What's p? Multiply both sides by 4. 1/2 times 1/4 is 1. Okay. So now I'm not a huge fan of mixed numbers, but this wouldn't be the worst place to use one. If you add an 8 to a -2, you get -1 7/8. Or -15/8. Either one of those is fine. Your directrix then has to be at a vertical line, since it's doing this, at x equals -2 1/8, or -17/8. Sometimes a mixed number, it makes a little bit more sense to use. It's a little bit easier. Yes, ma'am. What line? It's the directrix. The directrix is the one that would go through both sides of the parabola. It's a y squared parabola. It's got to have an x equals directrix, whereas if it's an x squared parabola, it's got a y equals directrix. The opposite of p value. It's all the same stuff we've been doing. Nothing's changed. It's just got crazier numbers. The p value is the distance from your center to your focus. Okay. The opposite of p is the center to the directrix. So if I added 1/8 to -2, it gives me my focus. If I subtract 1/8 from -2, it gives me my directrix. I'm just adding, subtracting an 1/8 to -2 to get my 2 points, or 2 values, excuse me. Okay. Really, it's all the same stuff we've been doing, guys. Just the numbers get a little crazier. It's a little bit crazier on the numbers. Okay. What I wanted you guys to do, I don't remember, I think I posted it already, on the same PDF file. I believe I had you guys doing those 6. Of the first 3, of these, it's just get into the conic form The last three is conic form and graph label everything. Graph and label everything, where it's vertex, co-vertex, foci, centers, all that stuff. Okay. And then, like I said, I posted a PDF file that had, I think it's like 8 more of the same style ones with the answers and the, I think a rough sketch of it, of where all the vertices and stuff are. These are all the answer guides if you want to look at it. They're all there. That's why I picked these ones instead of the ones that like above them, because those just tell you whether or not it's an ellipse or hyperbola. I don't have you guys just do that one part. I have you guys do the whole process. So that's why that does that. We'll go through these tomorrow if there's any specifics, and then we'll start doing some more of those funky number ones. I do have a hard copy of the more of this style where you have to click the square if you want. Otherwise, PDF is online. But I gave it to the other guy. So the answer guide for this one is already posted for this one. I'll just pass them on. There's more. Oh. There's extra ones. Good luck. Hold on, guys. Hold up. You answer this before I have to answer it four more times. That's the homework. These are just extra problems if you need more practice and whatnot. Of doing the square. Okay? These answers are already posted. The other ones you just gotta find. What? Yeah, what do you got? Oh, let me pause this real quick. Before I get back.